Today we're going to look at midpoint of a line. Let's start by labeling some of our endpoints of our lines. We have vertical, horizontal, and a diagonal line. So point D is negative 7, 9, and point E is negative 7, 3. So we have these two labeled. Let's label point A is negative 9, negative 6. Point B is negative 1, negative 6. Point H here is 6, 7, and point G is 2, 2. Now, as the title says, let's look at some of the midpoints of the line. So when we have this vertical line, it's pretty easy to see what point F is, the middle, because we can count halfway down the line and put a dot there, and we can just count where that is. So if we were to count over, it would be negative 7, and then this is 1, 2, 3, 4, 5, 6 high. So our midpoint for F is at negative 7 and 6. Let's also look at this one. So likewise, in a similar manner, the midpoint for this line, we could easily see where it is. We could sketch it, and we could count that it's negative 5 and negative 6 down. So finding a midpoint of a horizontal, which is this way, or vertical line is fairly easy. But when we look over here at this line, if we were to estimate where that midpoint is, it really would just be an estimate. We don't know exactly where the middle of this is because we can't count the squares when we have a diagonal line. So we need to come up with some kind of a way that will give us the midpoint of any line segment that will work in any case. So let's have a look at this. Now, with this one on a vertical line, we notice that the x-coordinate of the midpoint is the same as point D and E, so that doesn't give us too much information. But what about 6? Let's think of 6 for the y-coordinates. How could we have got an answer of 6 with 9 and 3? Okay, so try to think of what can you do with 9 and 3, add or subtract or divide or multiply, anything that you could do, or a combination of those things to get an answer of 6. Okay, so think about that for a minute. And also let's look at here and see if, whatever you think of for this, see if it works for here. So the negative 6, the y-coordinate here is the same as the y in point A and B. So that doesn't give us too much information to work with. Let's work with the x-coordinate here. Our answer was negative 5, and we know that's correct. But how could we have got that without counting, just by using the numbers negative 9 and negative 1? So we have negative 9 and negative 1. Do something with those, either add, subtract, multiply, divide, or a combination of those to give us an answer of negative 5. So after you've thought about that for a bit, hopefully you came up with this. Let's see if this works. What this says is you can take your two numbers for the endpoints for x and y and add them and divide by 2. So let's see if that was the trick. So here, in order to get the 6, let's see if that worked. The 9 plus 3 is 12 divided by 2 gives us 6. Ah, it worked there. Let's see if it works here. The negative 9 plus the negative 1 is negative 10 divided by 2 is negative 5. So yes, indeed, it does work. It worked for the x and it worked for the y in this case. So now we have a concrete way of finding the midpoint for this point over here. So let's go ahead and do that. So 6 plus 2 is 8. Divided by 2 is going to be 4, and 7 plus 2 is 9 divided by 2 is going to be a decimal, but that's okay. So this point is actually at 4, 4.5 exactly. So now we don't have to guess. Let's use this formula now that we know it works and try a couple of examples. Okay, so now this time we don't have sketches, and that's fine. We want to find the midpoint of these two endpoints of our line segment. Now remember that a line segment is a part of a line. A line continues forever, so these are the two endpoints where the line stops. So quite simply, we know, using our formula, it's x1 plus x2, so this is x1 plus x2. It doesn't matter which order you add in, divided by 2, and then we have our y1 plus our y2 over here divided by 2. Okay, and doing some simple math there, 7 plus 1 is 8 divided by 2 gives you 4, 5 plus 1 is 6 divided by 2 gives you 3. So this is the midpoint of a line that would be drawn from this point to this point, or vice versa. Okay, let's try another one. Um, and this time it's okay, we're not subtracting, so we don't have to worry too much. We can handle our negative signs. So our 3 plus our negative 7, but you still do want to be careful. Put your negative numbers always in a bracket. That's safest. Then we have negative 1 plus our 3, both divided by 2, and that works out to negative 2 comma 1. Okay, so double check the math there and see if you can get that. Let's try another one. 10 plus negative 2 for our x's, negative 1 plus 4 for our y's, both divided by 2. We get 4 comma 1.5. So sometimes you do get decimals, and that's okay because it's probably a diagonal line. Let's try one last one. Negative 1 plus 5. Okay, be careful there. That's 4 divided by 2. And then we have negative 4 plus negative 6, and that'll be negative 10 divided by 2. So we have to be good at integers here. We get 2 comma negative 5. So go through the math and see if you can get those same answers. Okay, now there's one practical question that I want to do with midpoints of a line. And midpoints of a line come in handy when we're talking about medians. So let's define what a median is. So first of all, on our page, we want to make sure that we have triangle ABN drawn. So we have triangle ABN. A is at negative 6, 0, B is at 4, comma 6, and N is at negative 2, comma negative 4. So first of all, we're going to find the midpoint of AN, and we're going to draw a median to find out what a median is. And we're going to label that median BM. And labeling in analytic geometry is very, very important. So always have your endpoints labeled like this, and always have each line segment labeled with a letter to denote the two endpoints. Okay, so let's go ahead and find the midpoint of AN. So we want to add our x's and divide by 2, and add our y's and divide by 2. So we've done that here, and we get negative 4 comma negative 2. So if we go and we find negative 4, negative 2, our midpoint is right here, and that looks about right on our diagram. So our midpoint is negative 4 comma negative 2. We put a dot there. And it said to draw a median from that middle point across to the vertex of the opposite side. So if we look at our definition, it says a line that joins a vertex to the midpoint of the opposite side. So that was what we've drawn over here. Now this triangle would have two other medians as well, but we're just going to sketch the one for now. Now the other thing I need you to know how to do is determine the equation of that median. And when we say equation of a median, it's really the same as saying equation of a line. And when you think of equation of a line, you should always think of a y equals mx plus b. So let's start. When we think of y equals mx plus b, we need to find two things, the m and the b. So the m is the slope of the line. We want the slope of this dotted line. So the slope is given by our old formula, y2 minus y1 over x2 minus x1. So these are the 2 points we're going to use, b and m. So we'll subtract our y's, which is 6 minus negative 2, which we have here. and subtracting our x's in the same direction, 4 minus negative 4. That's what we have on the bottom. And that gives us 8 over 8, which is simplified to 1. So our slope is 1. And as we said, we want to use our y equals mx plus b. So I've put that in a box because it's very important. So we've put in what we know so far. Our slope is 1. And now we have to solve for b. And recall that solving for b means that it could be the only variable. We can't have any other letters in that equation. So I need to put in something for x and y. X and y is a point on the line. Any point on the line will do. And we actually know 2 points on the line. We know this point and we know this point. They are both on the line. So you could choose either point, use a point on the line, and I think using the one with positive numbers is easier, so we'll plug in 4 is our x and 6 is our y. Now we just have to solve for b. So 1 times 4 will be 4, and that taken over to the other side will be a negative 4, so we did a 6 minus 4 is 2, b is 2. And we're not quite done yet. We have to write our equation of our median line, which is written like this. So always have a therefore statement. Y equals 1x plus 2 is the equation of the median. And notice that we don't have to write a 1 because it does look a little bit strange, but this implies that we have 1x. And this was the b that we found from solving using a point. And notice that b is our y-intercept, so let's find where 2 is right here. Notice that our line does cross through 2 on the y-axis. That's our y-intercept, and that's how you know that you made your equation correctly.